Hello, and welcome to this tutorial on sequencing and partitioning of MDAO workflows in the operational collaborative environment. Before going to the operational collaborative environment, I first want to explain to you what is sequencing and partitioning of MDAO workflows. So let's start off with sequencing. So one of the goals within MDAO problem formulation is to minimize the execution time. And this consists of two different elements. One is to minimize the number of iterations, and two is to minimize the execution time per iteration. And with sequencing targets both goals. So it tries to minimize the number of iterations and to minimize the execution time per iteration. So let's look at an example problem, right? So we can see here we have 5 different disciplinary tools, and they are interchanging some data, right? As you can see with the off-diagonal elements, okay? So within this problem, there are 3 variables that need to be converged if we would place a converger around these 5 disciplinary tools. We have Y3, Y4, and Y5. However, we can also change the order of the disciplinary competences, right? So if we change this, we can see that now we only have 2 variables in the feedback loop that we need to converge, right? And this is called sequencing. So changing the order of the disciplinary tools such that the number of feedback variables is minimized, because minimizing the number of feedback variables will lead to a reduction in the number of iterations. Furthermore, the sequencing algorithms also checks whether some disciplinary tools can be run in parallel, which is the case, for example, here with D1 and D5. They are independent of each other, so if we put a convergence loop around it, we can see that D1 and D5 can actually be executed in parallel, which is the case here. And this will lead to a reduction in execution time per iteration. Now let's see how this works within the operational collaborative environment and how we can apply the sequencing algorithms to our MDAO workflows. So for this, we first go to the Workflow tab. And then within KADMOS, we can see here a tab which is called Execution Order. Now if we look here, we see the execution order, and we have here a setting, function order determination setting. And that is where you can select an algorithm that is implemented in KADMOS that does the sequencing for you, right? So we have implemented 3 different algorithms, which are the single swap, the 2 swap, and the hybrid swap. And if you select one of these 3, then KADMOS will automatically determine the best execution order for your problem. An alternative what you can do within the OCE is to set this setting to manual, and then you have this table here where you can set the execution order yourself, right? So you take then a discipline, and if you say edit, you can here change the place where the discipline is being put. Okay, and that's all. So by setting this algorithm, the execution order will automatically be determined by KADMOS and implemented in your MDAO workflow. So next up is partitioning. Okay, so partitioning is dividing the design competence in several groups that can be executed in parallel. To show how this works, let's take the example we also had for the sequencing, right? So we have here 5 disciplinary tools with a converter around it. Well, if we now give all of the tools an execution time, we can calculate how much time it takes to do 1 iteration, right? In this case, it will take 60 minutes per iterations. Why? Because D1 and D5, as stated earlier, can be executed in parallel. So after 5 minutes, both D1 and D5 are finished. So we have 3 plus 5 plus 5 is 60 minutes. Now, what we can also do is divide these disciplines in 2 different partitions that can be executed in parallel. So that's shown here on the right, right? So we have the first partition, which consists of D4, D3, and D1. And we have a second partition, which consists of D5 and D2. If we now look at their execution time, we can see that both partitions have an execution time of 10 minutes, right? So this is a reduction of 6 minutes per iteration. However, this comes of course at a cost. If we look to the problem on the left side with no partitions, we can see that we have 2 variables to converge. If we look at the problem with the partitions, we see we have 4 variables to converge. So even though with 2 partitions the execution time per iteration has been reduced, probably the number of iterations will increase as there are more variables to converge. So in order to deal with this trade-off between execution time per iteration and the number of iterations, a partitioning algorithm has been developed within KADMOS. So how does this algorithm work? So for a given number of partitions, the algorithm tries to minimize the execution time per iterations. So how does that work? It tries to balance the execution time per partition such that the partitions have more or less the same execution time. Right, this is beneficial because then one partition does not have to wait for the other partition to be finished. So this way the execution time per iteration is minimized. The next step, it tries to minimize the number of variables that need to be converged. So this is done by minimizing the connections between the different partitions, because those are the connections that need to be converged. And also the sequencing algorithms that we saw previously are also applied within a partition, because also the feedback within one partition also needs to be converged. Okay, so let's see how the partitioning works within the operational collaborative environment. Okay, so for that we need to go to the top workflow partitioning, which is under the top workflow. Okay, so then the partitioning starts with setting some general settings. And the first one is to allow local convergence. So a local converger is a converger that is placed around a specific partition, right? So each partition can have their own local convergence, and then the feedback variables within a partitioning will be converged first before the connections between the partitions will be converged. So let's put that on no for now. The second setting is to use the runtime information of the different design competences. And to use that, we first need to add runtime information to the different design competences. So that can be done under the tab Design Competences. And then you can see here a table with all the design competences that we have within our MDAO problem, right? So if we click on a design competence and then we click on Edit, we can see here we can add an average execution time to this design competences, right? And then you click on Edit. Okay, and then I already added some execution time to all the different design competences, and you can see them here. Okay, so once we have added the runtime or the execution time to the design competence, we go back to the workflow partitioning. So we have to set this setting, we set it to yes, so we want to use the runtime information. Then we can ask KADMOS for an advice, right? Because as I explained before, the algorithm implemented in KADMOS calculates a partition for a given number of partitions, but we don't know how many partitions we want to have, right? So what we can do here is to ask KADMOS to evaluate a different number of partitions, right? So we can select here the ones that we want to be evaluated, and then we can say to give the full Pareto front yes or no. So let's put it on no for now. So for now, then we have everything set to give an advice on partitioning. So we click that button, and then KADMOS is calculating the partitioning for these number of partitions. And the result can be seen here, right? So what are we looking at? KADMOS generates a plot in which on the x-axis you can see a runtime for one iteration, right? So the execution time for one iteration. And on the y-axis, you can see the number of variables that need to be converged, right? So what you can see here, option 1 is one partition. It has the longest execution time, but it also has the least amount of variables to converge. While if we take, for example, 4 or 5 partitions, the runtime for one execution, for one iteration has been reduced, but the number of variables have increased. Now what you can see here that is that, for example, 2 partitions will always be better than 3 partitions because they have the same execution time per iteration, but 2 partitions has less variables to converge. Exactly the same for 4 or 5 partitions. So what we can also do is do not give a range to KADMOS to be evaluated, but we can ask KADMOS to give the full Pareto front, right? And then we will only see the partitions that are actually on the Pareto front. So if we click again on give advice on partitioning, if we let KADMOS calculate it, we can now see only the best option. So we can see the Pareto front, okay? And now it's up to the user to determine, okay, which amount of partitions the user wants to add. So that's the next part. So here you can set the number of partitions that you want to add. So for now, let's put it on 2, right? And if we put it here on 2 and we say we don't want to manually add a partitioning configuration, that's also an option, but we don't want to do that. We want to use the one that has been calculated by KADMOS. We set it here to 2, and then we go back to workflow here. And we can say update workflow architecture. So I've already done that before, and then we can see here the results. So we can see the XDSM, and then we can see here that KADMOS has added 2 different partitions, right? So the initiator and unload are one partition. The movable generator, the kinematics modeler, and prototypes are the second partitioning, right? Now going back to the workflow partitioning, I already mentioned it, you can also add a manual partitioning configuration. If you put this to yes, then you can use this table to manually add your partitions. So what you can do, each row is a partition, and here you can select the different design competences that you want to have in your partition, and you can also say whether you want to add a local converter for that specific partition, yes or no. And that's basically it on sequencing and partitioning within KADMOS, using KADMOS within the operational collaborative environment.